Okay, today we're going to take a look at sequences and series, and I will be doing kind of the left column, and you can pause after each question to do part B of that question, or you can come back and do part B's at the very end. So the first is just reviewing the difference between A sub n and S sub n. I'm not sure if I wrote S sub n. Here's S sub n. So remembering when it's asking you A sub n, it's looking for a particular term of a sequence. So if we want to find the seventh term and we have a closed formula, we can just plug 7 in for n and see what happens. So I have 49 plus 2 would be 51. And then half of 51 would be 25 and a half. So A sub 7 is equal to 25 and a half. Number 2, finding the first 5 terms in a recursive function. So remember, recursive is different than closed. In closed, you can plug in exactly the number that you want. In recursive, you can't. In recursive, it's like reading a story. And if you had A sub k minus 2, A sub k minus 1, A sub k, A sub k plus 1, these are just relevant order to each other. So in this story, if we're at k plus 1, we're here. What does it tell us to do? Take A sub k minus 1, so this term, and add 2 times A sub k. So in our order, A sub 1 is 2 and then 5. So it wants us to take A sub k minus 1, which is the number 2, and add 2 times A sub k. And 2 times 5 is 10. So I'm taking 2 plus 10 to get 12. So now I'm going to slide these over. Now this is 5, this is 12, and now I'm looking again for the next term. So this tells me to take 5, because that now is A sub k minus 1 relevant to A sub k plus 1, and add 2 times A sub k. So I'm going to take 5 and add 24. Finding a sum on either a calculator or by hand. I'm going to show you on the calculator, but if you didn't have a calculator, this one would be a little bit too big because it's exponential, but you would plug in 1, see what you get. Plug in 2, see what you get. Plug in 3, see what you get, all the way up to 5, and then you'd add the 5 terms together. On your calculator, that is under the math key, and you scroll down to summation, number 0. And then where it says I equals, we're going to use the X variable key. So X goes from 1 to 5. And we want to do 3 raised to the X power minus 2. So that sum is 353. Nth partial sum. These all say going to infinity, but it's telling you what sum to take. So I'm taking the 5th partial sum. That just means you're plugging in 5 up here. So we're going to do number 4 the same way we just did number 3. Go to summation. X goes from 1, which one am I doing this time? The 5th partial sum. And we're going to say X plus 2. So that comes out to 25. Determining whether something is arithmetic. That means it's going up by a consistent amount each time, adding or subtracting. So in part A, it looks like it's going down by 2 each time. So yes, this is arithmetic. And the common difference is -2. In number 6, writing a formula. To write the formula, you need to find the first term and you need to find the common difference. I'm starting at term 2 and going to term 6. So in 4 terms, I've gone down how much? 93 down to 65. I've gone down 28. So that looks like my common difference would be 28 divided by 4, so it's going down 7 each time. I need to find my first term, so to go backwards, I would add 7. So that tells me that a sub 1 is 100. Once I know those two pieces of information, my formula is a sub n is equal to my starting term minus 7 n minus 1 times. Number 7, you are going to do the same way as number 6, so you can do number 7. At the end, they want you to use the formula to find the 20th term. I wrote down that the sum of a finite arithmetic sequence is this formula. So we learned about this when we talked about adding up all the integers from 1 to 100. So if you added up all the integers from 1 to 100, and then you started pairing together the first and the last term, see how all those pairs are going to add up to 101, and you would have 50 of those pairs. So if you have 100 numbers, you divide by 2, so you have 50 pairs, and you take the sum of the first term plus the last term. So for this problem, it would be 50 times 1 plus 100 is how I get my solution of 50, 50. 50 times 101. Next, if you have a starting salary and you're increasing your salary each time by 2,250, so determine the salary during the 10th year. So we need to evaluate a sub 10, so we need a formula. A sub n is equal to 34,000. I'm adding 2,250 n minus 1 times. We need to think about how many raises they're going to get. So year 1, their starting salary is $34,000. They're only getting 9 raises until the 10th year. So we're going to do 34,000 plus 2,250 times 9, because 10 minus 1 is 9. So that comes out to they're making $54,250 in their 10th year. And for their 10 full years of employment, we're doing the sum now of that same formula. So the sum n goes from 1 to 10 years. We've got 34,000 plus 2,250 times n minus 1 times. They're making $441,250 over the 10 years. You can do number 9, just finding the 50th sum with a calculator or with a formula. Number 10, determine whether the sequence is geometric. So that means you can multiply by a ratio. This looks like it's multiplying by 2. So yes, this is geometric, and the ratio is times 2 every time. Write an expression for the geometric sequence, and then find the 20th term. So in this one, I'm taking 16 and multiplying by negative 1/2 to get to negative 8, and this happens to be the first term. So to write a geometric sequence, it's the first term times the ratio, negative 1/2, and you raise it to the n minus 1 power. So now I'm going to plug in 20. And evaluate it. I'm putting the negative 1/2 in parentheses so that it will go between positive, negative each time, like the pattern is showing. So this is a really small number. I'm going to turn it into a fraction. Oh, it won't let me. And I don't know what half of 16 to the 19th power is. So it's close to 0. I guess I'll write it in scientific notation. Negative 3.05 times 10 to the negative 5th power. So practically 0. I want you to know how to find an infinite sum. So for an infinite sum, you take the starting term and you divide by 1 minus the ratio. That's only for infinite sums. So letter A is just a regular sum on your calculator, regular sum on your calculator. Let's look at part C. So part C, I can use this formula for because I'm going to infinity. You need to think about the starting term. So if I plug in 1, I get 7/8 to the 0 power, which is 1. So the starting term is actually 1, and I'm dividing by 1 minus 7/8. So 1 divided by 1/8 is 8. And I want to show you on a calculator, if I go to the sum of this sequence, let's just do the number 50, because we can't plug in infinity. And it's 7/8 raised to the n minus 1 power. So 7.9899 converges pretty closely to 8. My guess is if we did the 100th partial sum, it would converge to 8. So let's see if it'll tell me. Oh, 7.999. So it's getting very close to 8. So if I kept doing a bigger number, eventually it would tell me it's converging to 8. So you should have enough information to do the rest of this, and you can post the back and front of 903.